All right, so yesterday, some people asked me, so really in this section, and I want to highlight a couple of things. And we talked about it. I said the words. Maybe I need to start writing the words down, but we had two formulas for this section. Okay? The first one was that theta sub r is equal to s over r. And this is our central angle, and I think that's why I need to write it in words. I think somehow we're missing some of this stuff. This is the relationship to the central angle in radians. And I did write some of this stuff down, but I think ever since COVID, you guys don't look at your notes sometimes. S is arc length. And then R is the radius. And remember, these have to be in the same units. Then we did another formula in this section where we said the area is equal to 1/2 the radius squared times theta. Now, this is the area of a sector. Which is like a slice of a pizza pie. So depending on what they're asking us, we either use the red formula or the blue formula. Okay? And so yesterday when you guys were coming up and asking me for my help, some of you guys were trying to use this formula for area, or you were trying to use the area formula for length. And it depends on what they give you. So the reason I wrote that down is because the easiest thing to do is read it, see what they give you, and figure out what they're asking you to do. So they said find the exact length of the radius. So immediately I know they want us to find the radius of a circle with a central angle of theta in 120 degrees. Okay. That intercepts the arc length S, that is 2 pi over 3 miles. So if you had to choose a formula, I would go with the first one because there's S, there's R, and there's theta. What do I got to do first, though? Well, theta is in degrees. They gave me in degrees. And remember, for this formula, I need radians. So that's easy enough. I'm going to multiply this by pi over 180 degrees. The reason that I do that is because the degrees will cancel out. So then this becomes 120 over 80 times pi. And then I just got to reduce this. Okay? Immediately, if I divide both sides by 10, I get 12 over 18. Then if I divide both the top and bottom by 6, I get 2 over 3 times pi. So that's my measurement in radians. And somebody said, Mr. Adams, and I said it in class, and it's okay if you don't remember, but that little lowercase, not lowercase r, but the subscript r, when I say theta sub r, that means that this is in radians. Notice that Mr. Adams didn't put the r here, but once I started the conversion, I put the r. Okay, that's what all this stuff means. Okay, and I said it, but I only said it one time when we first went over it, so it's okay if you don't remember. All right, so I'm going to use this formula and plug the numbers in. Now this adds another element of tomfoolery and shenanigans in the sense that my formula is theta is equal to the arc length over the radius. While I know that my theta is 2/3 pi, and that's equal to 2 pi over 3 all over the radius. So then if that's the case, how do we, yeah, we'd multiply by r to get the r out. This r cancels with this r, and we've got 2/3 pi times r equals 2/3 pi. So then I've got to divide this side by 2/3 pi so I can get r by itself. Whatever I do on one side, I have to do to the other. When I do that, 2/3 pi divided by 2/3 pi is just 1. 1 times r is r. Hey, what's 2/3 pi times 2 or divided by 2/3 pi if you were to guess? Just 1. So my radius is 1. Actually, it's 1 mile because that's the original unit that they gave us. Now you might have different numbers, so you know there's that. But that's how you would do it. Okay? So I'll leave that up there for a second so you can